Welcome to the 6th video on how I use Photoshop to produce patterns. In this video I will demonstrate how I grade my blocks to make them suitable for multiple thicknesses of rubber sheeting. In this way, any resulting garment patterns that I might want to produce in the future can be used for any thickness of latex I should desire to make the garment from the very thinnest to the very thickest. If you are familiar with commercial patterns, you may also be familiar with grading. That is where we see multiple pattern templates for the same region of the body drawn at different sizes, and quite literally this is what they represent: templates for a region of the body scaled in size for different sized individuals. So for pattern templates that cover the upper torso region of the body, that templates may be drafted to a bust circumference of say 80 centimeters, but we'll also see a second set of templates drafted to a circumference of 84 centimeters. Another set for 88, another for 92, 96, 100, 104 and so forth. But the grading applied for different thicknesses, that is gauges of rubber sheeting, has nothing to do with sizing. Rather, we are applying reduction to the person's natural circumference measurements to make the blocks suitable for stretch materials, in our case latex. When we grade, we are taking a circumference such as the bust and waist and applying a certain percentage of reduction to make those circumferences smaller. So if our bust circumference was 100 centimeters, we might apply a 10% reduction, resulting in a new circumference measuring 90 centimeters. Any garment using that reduction therefore has to stretch 10 centimeters longer in order for it to accommodate our body. So the latex has to stretch around 11% more. But where do such figures come from? How do we know how much reduction, also known as negative ease, to apply for our different gauges of rubber sheeting? Very often manuals on pattern drafting will include such information, but where do the authors get such information from? So, as a writer of such manuals myself, where do I get the information from? Well, I do my own crude version of stretch testing. First I cut out a 20 centimeter square of rubber and make a note of its thickness. Here I am cutting out a 20 centimeter square of 0.3 millimeter thick rubber, and in the center of the square I draw a 10 centimeter square. The idea is to measure how far I can stretch this 10 centimeter square. So why don't I just cut out a 10 centimeter square and stretch that? Because the raw edges of rubber are more easily stretched than the internal areas of rubber, which would give us a false result, but also because it simply makes it easier to hold down the rubber as it is stretched. Here you see placed the rubber piece over a ruler, aligning the left-hand edge of the internal square to the 10 centimeter location. With my left hand firmly keeping this side of the rubber held down in place, I gently take hold of the right-hand edge and pull. The stretching will occur more down the middle of the right-hand edge of the internal square, and it is this that I observe and mark on the ruler how far it came out. So I see that for a 0.3 millimeter rubber it can stretch up to around 12 centimeters. So that is a 20% increase. Now the idea is that we are not trying to see how far we can stretch the rubber. If I wanted to, I could stretch it to around 30 plus centimeters before my poor weak muscles give out. That is now around 250% larger. In fact, if we had the ability or the machinery and tech to measure things properly, we would find that the rubber could stretch up to 600% larger than its natural resting state before tearing itself apart. But garments made to such extremes, even if we could stretch them to get our bodies into them, would literally be crushing and highly dangerous to wear. So the idea is that we are only gently grasping the rubber and applying just enough strength in the stretching before we begin to feel that the rubber will pull away from our fingers. So, for a 0.33 millimeter rubber, I see I can gently and easily stretch the rubber to around 12 centimeters. For a 0.2 millimeter rubber, so a little bit thinner, I apply the same amount of grip and strength in my stretching and see I can stretch the latex to around 12.5 centimeters. Doing the same for a 1.05 millimeter thickness of rubber, I find I can only stretch it to around 10.25 centimeters. If I do a similar test with a section of lycra which contains elastane, a synthetic rubber which stretches, and is woven so that on stretching the spaces between the woven fibres may also expand, I discover that it can stretch to around 16 centimeters, so around a 60% increase. Because lycra is capable of stretching more than rubber sheeting, we take care when using patterns designed specifically for lycra. Now, while I have so far taken measurements from 3 gauges of rubber sheeting, and could continue with all the different gauges, we do not need to unless we want confirmation regarding each one. We can in fact work with just one single thickness, ideally a thinner type such as 0.33 or 0.4 mil. So here we see the 10 cm square that was drawn in the center of our 20 cm piece of 0.33 mil rubber. When this was stretched and measured, it came out as 11.4 centimeters. Now I need to work out how much that increase in area through stretching is as a percentage. To do this, I first deduct the 10 cm square from its stretched 11.4 centimeter version, giving me a result of 1.4 centimeters. I next divide this result by the stretched square, and then multiply this by 100. This gives me the percentage value I need. This works out at 12.28%, which I have rounded down to 12% simply to make life much easier. And that is it. I don't need anything else. From this I can easily grade my patterns for any other thickness of rubber, as we shall see. So let's begin. I am first going to concentrate on the bust line. I first measure the bust line minus the 8 to 9 gap between the sections involved. This comes out at 43.4 centimeters. I next deduct from this result the 0.33 millimeter percentage of 12%, giving me a result of 38.2 centimeters. I now deduct this result from the bust measurement, giving me a result of 5.15 centimeters. This is how much I am going to shrink the bust line down by. The result is divided by 4 because I intend that the reduction will be applied in 4 different locations. These will be 0.41 for the back section, 0.9 and 11 for the side back, 8 and 10 for the side front section, and 0.12 for the front. At each of these points I shall be bringing them each in by 1.3 centimeters. So using the ruler tool I measure my 1.3 centimeters in from these points and dragging guidelines to mark their locations. I make copies of each of the 4 sections. I first select the back section to work on. Then using the direct selection tool, I drag a box over points 15 and 16 of the shoulder and point 41 on the bust to isolate them. By then clicking on point 41, I can then drag all 3 points in to the guideline location. What this ensures is that the 16 to 41 edge remains unchanged in its length, and so is still compatible with the 41 to 20 edge. I still have to make adjustments to point 15, but that will be later. Moving on to the side back section, I isolate points 21, 11 and 9 and drag these into the guideline location. For the side front I do the same. Isolate points 24, 10 and 8 and drag the lines into the new reduced location. And for the front I do the same for points 12, 24A and 13. Okay, now for the shoulder. My shoulder measurements come to 12 centimeters. I apply a 12% reduction to get 10.56 centimeters. This is deducted from the original 12 centimeter shoulder length, so I get 1.44 centimeters, which is divided by 2, 1 for each side of the shoulder, to see that each shoulder needs reducing by 0.7 centimeters. Selecting the back layer, I measure this 0.7 centimeters down the shoulder line, dragging in a guideline and moving point 15 to it without disturbing the orientation of the shoulder. On the side back, I measure up the shoulder from point 21 and move the shoulder point to the location. I repeat all this for the two front sections. Moving on to the waist, I measure the waistlines of each section and add them together. This comes out at 36 centimeters. I apply the 12% reduction, making the reduced waist 31.68 centimeters. And I deduct this from the original waist length to get 4.32 centimeters, the amount by which I need to reduce the points in by. Now, at the waist darts 39 and 31, I should bring these in by the same amount as the reduced bust points, which was 1.3 centimeters, or 2.6 centimeters in all. This maintains the 12 to 31 and 41 to 39 lengths so that they remain compatible with their neighbours' edges. For the side edges, points 35 and 37, I take the 4.32 centimeter waist reduction and deduct the 2.6 centimeters applied at the waist darts, leaving me 1.72 centimeters. I then divide this by 2 to give me 0.86 centimeters. Call it 0.9. And it is this that I use to bring in points 37 and 35. All these reduced waist points are brought in horizontally from their original locations. And that is everything. All reduction has been applied to produce a new block with 12% reduction. Using the direct selection tool, I remove the colour fills from all the sections, change their opacity back to 100%, and make the reduced sections have red outlines, just for clarity purposes for the time being. I then make sure that the original and 12% reduced sections are contained within their own single layer folders, and label them as such. Next, I'm going to produce a 6% reduced block. I make a copy of the 12% folder with all its contents inside, and this time I do not have to make any more calculations, because from this stage onwards we can judge everything by eye. All we are looking to do is to move the various points to halfway locations between the original sections, which had no reduction applied to them, and the 12% reduced down versions. I have coloured these 6% reductions in green to make them a bit more obvious. Most of our reductions occur along the horizontal axis, and as such, we can use dragged-in guidelines and our underlying grid to help us out here. But in some places, such as at the inside shoulder points, where reduction is occurring along a diagonal axis, it can be helpful to first draft using a pen tool guidelines that connect the original and reduced versions together. After producing the 6% reduced versions, I make copies of both it and the 12% versions. Things now begin to speed up, for now I can work with both of these simultaneously to adjust them to their new reduction locations. In this case, I am bringing them both in by 1/3 of the distance. This gives me my 4% and 10% reduced blocks. After this I make further copies and produce my final 2% and 8% reduced blocks. So things start off slow in so much as we have calculations to make, but it soon begins to pick up speed and get easier. So in the end I have my original block made up to a person's individual measurements, followed by 6 graded blocks from 2% to 12%. How many graded blocks we produce is entirely up to us. Knowing now the individual distances involved between each graded version allows us to continue including further reduced blocks if we so wish. It even allows us to produce blocks in the opposite direction, going outwards from the originals rather than inwards. In this way we are producing blocks that have ease included, that is, for looser fitting types of garments. At this point, when all reduced blocks have been produced, I select all the drafted layers, from the original sections to the 12% ones. Using the direct selection tool, I drag boxes over the individual nodes of the points to reveal their manipulation guides. In most cases all the guides will be the same length and have the same orientation, but there can be cases where we may have made adjustments in length and angle when producing the first, most reduced block. By highlighting the guides, it allows us to see if we need to make additional adjustments across the intermediate grades between the original and the fully reduced version. It is a good idea to label our graded edges with the percentages used, natural for the person's natural measurements down to the 12% reduction first created. This is the equivalent of saying that as we go from natural to 12%, we will first go into the thickest types of rubber, around the 1 mil area for the 2% reduced blocks, 0.9 to 0.8 millimeter thick rubber for the 4%, 0.7 for the 6%, 0.6 to 0.5 for the 8%, 0.4 for the 10%, and 0.3 for the 12%. Of course, even at just 2%, we can still use the thinnest gauges of rubber. We still get a skin-tight fit, but one that is very relaxed. And we can use the greater reduction percentage for the thickest rubbers, but always keeping in mind that the fit will be much more compressive and difficult to wear. But by having a block in which multiple grades are incorporated, it opens up a lot of freedom to choose just exactly what latex sheeting we might use, how skin tight we may want it, and it allows us considerable play to alter the compression in different regions of the body, going for tighter fits say around the waist to produce more streamlining, and more relaxed fits around the bust to ease up on the flattening of the breasts, or increase flexibility into the arm. Anyway, the block is now finished, so join me next time when I will begin to see what kind of garment I might want to make from it.